Hello, today is our fourth lesson in our Universal Programming course, and today we will be talking about collections or containers of objects. This is a very important and basic concept in modeling and programming, and as usual in our course, as you remember, it's a very important thing that we wanted to do. As opposed to other courses, is we want to always connect our models and our programming to the real life examples and real life concepts. So today we will be talking about collections. Okay, so what is a collection of objects? So collection of objects is a set of objects of a certain type that we want to treat as a whole entity in our models and in our programming, and basically we treat it as a whole in our life, as a whole thing. So let's take an example. A box of pencils. So we have a box and we have pencils inside this box, many of them, and each of the pencils can have its own attributes and characteristics, like color, like length, like material from what it's made. In this case, our objects are pencils, but the box of pencils will be our collection. And we want to treat this whole box, this whole collection of pencils as a single entity. So we can move it as a single entity from one place to another place. We can throw it away, we can buy it in the store. We want to handle it as a single entity. So we want to move it, we want to do different things with it. Now, another important thing is that this collection can contain objects of a certain type. Now, in this case, the type is pencils. It could be a more generic type of things, and if collection contains this generic type, then it can be more specific types that can be derived or can be substituted for particular incarnations in another instances of this collection. So, for example, we can have another box, and the type of this object may be writing device. And writing device could be a pencil, and another one could be a pen, and another one could be something else of the writing device, and things of that nature. Now, when I'm talking about box being a collection of pencils, I'm not really precise in this definition. So we should differentiate between, we should make a difference between a box, as a separate object with its geometry, with its own characteristics, and the collection of pencils that are inside the box. So please separate these two things. So the collection of pencils is just the set of all the pencils that are going together. What are actions that we can do with collections that are exposed as APIs, application programming interface in programming? So obviously, when we have a set, we can add an object to the set. So we can take a pencil and we put it into the box, and now the pencil belongs to the collection. Or we can remove the pencil from the box, and now the pencil does not belong to the box anymore. And these are all actions that change state of the collection. We were talking about the state and what does it mean, the state change. Yet there is another action on the on the collection that's very important. That is what basically collection is made for. And this action is called iterate. Iterate means iterate through all the objects that belong to the collection. So iterate means take each object separately and give it to the requester. So we can look at one pencil, we can look at next pencil, we can look at next pencil, and therefore we go through all the pencils that are in the collection. These are the main interface or the main actions that you can do in the collection. What types of the collections we may have? There are many different classifications of collections that may exist, but I propose this type of classification. First of all, there are ordered collections and there are unordered collections. So ordered collections are those collections where the order in which objects are added to the collections matter. Unordered collections are where the order in which objects are added to the collection does not matter at all. It's not remembered inside the collection. It's not needed. So let's go into examples. So the most well-known ordered collection is a queue. In the queue, we add another name for a queue is FIFO. F-I-F-O, first input, first output. So queue works like that. We add an object to a collection, and we add another object to a collection, and we add another object to a collection, and they are all being added. This is add. So they are all added, coming one after another. And when we remove objects from a collection or delete objects from a collection, they are deleted from the opposite end with the same order. So this is remove. So when we remove objects from the collection, next one is removed by the next remove action. There is also another type of a ordered collection that's called a stack. Everybody is supposed to be familiar with a stack, and this is LIFO or LIFO, last input, first output, where we add objects in the same way. This is the way that it's added, but we remove from the same end that we add. So it's removed in the same way. So the last object that was added to the collection is removed first. And there is also another type of collection, ordered collection, that probably you are not familiar with. It's a little bit more exotic. It's called deck, like deck of cards, where you can both add and remove objects to a collection from any end. You can add from this end, or you can remove also from any end. These are ordered collections. Now, unordered collections are a little bit more and at the same time less complicated. So unordered collections we can put as a picture in a these are all objects. Their position doesn't matter. But what can we do with such collections? It can be completely unordered and unkeyed collection where we can just iterate through objects, and the order in which we iterate through objects is undeterminate. That means that nobody knows, nobody can predict. We add them in one order, and in which order we will iterate through them, nobody can or remove them from the collection, nobody can say. There is another type of unordered collection, that's searchable collections. In this case, each object may have a key as part of the object itself, and this is very similar to objects in the database. So when we ask for an object in the collection, we can have an action that is called find, and we supply a key to this action, and this action is supposed to find the object that has the key that corresponds to the key that we supplied to it. So let's suppose these keys are equal, then it will return us object with this key. That's basic classification of objects, and what I want to just add to it, that there is totally no relation between those objects in the collection. Those objects, they don't know anything about each other. They don't know that they belong to the same collection. They don't have any connection between them as part of the collection creation. Unlike more complicated structures like graphs, like trees, where different objects are connected in certain ways within the collections. Another thing is that collections are one of the basic concepts of object-oriented programming, and therefore they are implemented as libraries in object-oriented programming standard libraries like C++ and Java, and in C++ it's STL containers and boost containers. So I will not explicitly probably explain or provide material of how it's coded. It's all written in books and on the internet. So what I want you just to understand is the concept and to know where to look for information about this concept. Thank you. That concludes our talk about collections. And the collections will be used extensively in our next lessons. Thank you.